our numbers have settled, which means we are ready to begin. Hello, everyone. Welcome to the third webinar of the Preparing for the PAT course 2023. We are live streaming on YouTube as well, and the recording will be made available to you tomorrow. My name is Kat. I am the Physics Access Officer at Oxford University. My pronouns are she and her. And I run most of our programs for secondary school students, including all of our stuff to support people interested in applying to study physics here in Oxford, but also at other competitive universities. This session is being recorded, as I've already said. Live streams on YouTube will be made available for you tomorrow. Quick reminder for some of you, an introduction for the rest of you to our housekeeping rules for those of you on Zoom. During our session today, you will be able to use the Q&A for any questions that you would like to be addressed. I'll let you know when we switch that on and it's ready for you. You can also access the chat to share your answers and share thoughts. Again, I'll let you know when that's available to you. Please keep it polite, keep it kind, and most importantly, do not share any personal details or information while we're in that session. Also, do make sure if you want anything answered, it doesn't go in chat, it stays over on the Q&A. If at any point this evening you are feeling unsafe and would like to contact the hosts and panelists or our safeguarding lead, you can do that through private messaging and we will make sure that we try to resolve that as quickly as possible. So that is our housekeeping session, which means we are ready to move on. We've had loads of new joiners this week because we had our open days last week. So I'm going to start with a reminder of what the PAT is and what this course that we're here for today also is. I'm not going to take questions during this section. I'm just going to talk for a couple of minutes. And if we have any questions, hopefully we'll have time at the end of our session. So first things first, the PAT is the physics admissions test at Oxford, and it must be sat for all candidates for physics, physics and philosophy, engineering and materials science. Your result on the PAT forms part of the information which admissions tutors use to decide who is shortlisted for interview. In order to sit the PAT, your school must register as the test centre, and then you must be registered as a candidate. In the vast majority of countries, the PAT this year will be in a hybrid format for the first time. This means there will be questions on screen and a paper answer booklet, which will then be scanned and returned to us here in Oxford for marking. And your teacher or whoever invigilates the test will have all of the instructions for that. The online test will include a built-in on-screen calculator. This webinar is part of the PAT on behalf of all subjects who require the PAT. So those ones listed that we've just said, physics, physics and philosophy, engineering and materials science. The Preparing for the PAT course is a series of 8 webinars, which we are on the third one of, alongside some problem sets and some summer assignments. And we hope that over this period of time, we provide you with all the information that you need to take the PAT, to help you prepare for the PAT, and to be confident at going into interviews if you are shortlisted. The timetable on the screen at the moment is part of the timetable, which is at the bottom of every main PAT email. And it will always be highlighted with where we are so that you can follow our progress. In each session, I'll fill you in on any updates or news in the segment that I'm doing right now. And especially as we get closer to key dates, I'll be making sure you have reminders of that. As I've said a few times, this is our third webinar, and you can see from our colour highlighted block that in the first, we are in a teacher-led problem-solving webinar, So in our first week, our first webinar, we had a session led by our teacher, Rachel, who works very closely with us. She gave us a whistle-stop general problem-solving session, which included things like dimensional analysis and lots of hints and tips about diagrams and about notation. Following that first webinar, we shared a set of problems, which 2 of our undergraduates then took you through the solutions to in our last session. This week, we are in our second study focus session, and this will be led by another teacher who we work closely with, Dr. Justin Palfreyman. He is going to build on some of the work which Rachel started in our first week, and he's also going to talk you through some more problem-solving techniques. If you haven't had a chance to watch any of our webinars so far, do not worry, they are available online. We email them out every week, but you can also head to our course materials page, which looks just like the screenshot that I've put up just now. So at the top of our page, we have an introduction to physics problem solving. That goes into a bit more detail than Rachel was able to in just one session and includes some of those concepts as well. Underneath this, all of our sessions are highlighted and all of the links. So you'll be able to access the problems that were used, recordings and problem sets which have just been solved. The link to this page comes out in every email, so you don't need to hunt around for it, and it's updated after every session and clearly labeled so that you can find everything you need to. And in fact, all of the information that both you and your school need is easy to find. It can be found at this site, which I will also share with you in tomorrow morning's email. This is the most up-to-date page, and it's the one that you need to check first for any information that you need. It also has an FAQ page, frequently asked questions, which is really useful. The most recent update on this page, and that's relevant for you all, is that your school is now able to register as a test centre. So that first step of preparing for the PAT in October this year is ready to go. That sounds like a really big deal and like a huge thing that you need to go away and organise. But trust us, your teachers are used to doing this behind the scenes. They'll do it for lots of big exams, not just for the PAT. Okay, so your school will get all of the details for this. This isn't something you need to worry about. But if you are concerned, maybe if you're a school that doesn't often send people forward for the PAT, feel free to mention it to your teachers, send them these links after we send them on to you, and also direct them to us if they have any questions. Okay? Just a quick note that if you are applying, but you do not attend a school at the moment, so for example, if you're on a gap year, you can still apply to sit the test at school or a venue, which has already registered following that link, but you won't be able to do that until candidate registrations open on the 1st of September. As I quickly mentioned earlier, the test format is a new one. It's not a big change though, because the questions are really similar and the syllabus is completely unchanged. But even though it's not a big change, we don't want anyone feeling anxious about it. So you'll be able to access a trial version of the test screen, so you can see what that looks like in advance, and you'll be able to try out that calculator as well. It's not quite ready yet, but I'll update you and show you that as soon as the new format is ready. So I think that covers where we've got to now. That's my quick PAT introduction, quick update. I hope it was helpful. As I've said, I'll take any questions at the end of our session today if we have time. But for now, I'm going to stop screen sharing. I'm going to open up the Q&A and our chat, and I'm going to hand you over to our lovely Justin Palfreyman, who's going to lead today's problem-solving session. With no further ado, I have stopped my screen share. Justin, thank you so much for joining us today.
Thank you for having me, Kat. It is very stormy in East London at the moment, so you went fuzzy for a couple of moments. Hopefully I'm not going to go too fuzzy, but if I do, just bear with me. I think it's likely just to be the lightning that's catching us out.
Absolutely. So, I'm not too far away from you, Justin, so it would make sense that I was caught by exactly the same little storm as you were.
Lovely. We've got 80 minutes and we've got 10 questions. So that works out roughly 8 minutes a question. Some questions are harder than others. So I'm going to give you somewhere between 5 and 10 minutes to solve these questions. And I'm going to be dropping in kind of like little hints as we go along. So hopefully you've opened up the document. It's a 4-page document. And the first page has a question on with a diagram that looks a little bit like this.
Oh, let me pop that in
the chat for everyone. So you want access to these questions. The way that you respond is you pop your answers into the chat and I will give you a shout out if you're right, or I might tell you that you're too high, too low, and I might just ignore you if you ignore units or have crazy significant figures. So if you're watching on YouTube and you want to be interactive, please get off YouTube and get logged into the PAT course so you can get on Zoom and so you can be interactive with me. All of these 10 questions, I want to banish calculators. It used to be for a long time that calculators were actually banished from the PAT. Now they're a little bit more lenient, but you do not need them. These ones are mental arithmetic and trying to find tricks, essentially. This first one, I stole from a primary school exam in Singapore. So that's kind of giving you the level of how easy these things should be. So most of these ones, they look trickier than they actually are, but there is generally a trick or an approach that will solve it very simply. So I don't know if you're fans of the 1% Club with Lee Mack. I don't watch it for Lee Mack, I watch it for the questions. I enjoy those kind of problem solving questions, and a lot of being a physicist is about being able to break down questions, spot tricks, spot symmetries, spot transformations that you can make in order to simplify the problem from something that would be horrendous to solve to something that is actually quite straightforward. So this is the first question. We've got a few answers in the chat already. So let's have a look, see if anybody's got it correct. Oh, there is a correct answer. We've got a few people saying 60. Don't say it to everybody, please. If you can just say it to the panelists, that would be helpful. The answer is not 60, but thank you for the centimeters squared. I'll tell you that the answer is higher than 60. And if you don't want a spoiler, do not look at Anima's answer, or Kitchan's answer, or Matthew's answer, or Nihar's answer, because you've got it correct. And again, do not spoil it by trying to look at the answers in the book, because that's not playing the game. So if I've told you that you've got it correct, move on to question 2, and I'll start dropping hints in about a minute, which will make this very straightforward. Paula, you are too high. Ben, you are correct. Yeah, so it's better to just share your answer with me rather than with everyone. So to hosts and panelists. Otherwise, you might spoil it for someone else who might just catch your correct answer in there. Linhan, you are correct. Charlie's correct. Looks like lots of people getting there. Katerina, yes. Callum, Athava, Peter, James, Sashin, lots and lots of correct answers. Now, well done, Harry, as well. Jinawi, too high. Okay, first little spoiler coming up. All I'm going to do is just draw some dashed lines. Yes, Eliza. Okay, Rohan, units. Scroll down on the page a bit. Unfortunately, this is a PowerPoint slide, so there's no scrolling down on the page here. You might want to log out and come back in. That tends to fix things on Zoom more often than not. Okay, so I think we're about ready to move on to the next one. Lots of right answers, more right answers than wrong ones. Curious why I got so many people at the start go for 60 centimeters squared. Just thinking that it was maybe half the area, but I guess maybe you didn't spot this extra area in this rectangle. So once we've drawn in these dashed lines, it essentially becomes trivial because this side is going to be 2 centimeters that you can see from 4 minus 2. And then this side of this rectangle is going to be 8 centimeters that you can see from 12 minus 4. So we know that this area is 16. And then when we look at the rest of the shapes, well, they're all triangles. So it's going to occupy half of the remaining area. So the remaining area is 104 centimeters squared once I've taken away this rectangle. So half of that plus that 16 back in gives us our 68. Okay, we've got an answer for question 2. Joe's come in. It's too high. So question 2 is about a ball at the top of a frictionless slope. The slope can be all sorts of shapes. And if it starts off essentially stationary, we just give it a slight tap. When it comes out at the bottom, it's traveling at 4 meters per second. So I wonder if instead of giving it a tiny tap, what if I kicked it at the top so that it was rolling with a velocity of 3 meters per second? How fast would it be coming out at the bottom? That's the question here. Victoria, no. Emily, yes. Will I share this PowerPoint? I will share it with the authorities. I think I might have already shared it with the authorities, but if not, I will share it again. And certainly your mentors, your student mentors, if you're in the mentoring group, will have access to this. And if they choose to share it, then yes. However, this is also being recorded on YouTube, so you can find it back on there as well. Okay, more answers coming in. There's a couple of right answers, Anima and Nihar. There were some who were a little bit too high. Let's just find some names on that. Carol, too high. Correct is Peter, Troy. Victoria, nice, you corrected yourself, but then you forgot the units. James, you're too high. Linhan, yes. Elliot, yes. Talia, are you using a calculator to get such a random number? No, too low. No calculators needed for this. Kitan, yes. Sashin, no, too low. Yitan, yes. Callum, yes. Ubaydullah, too high. Alice, yes. Okay. Talia has asked whether we assume G to be 10. Does it matter? I would say no. I've not even told you what planet we're on, to be honest. And I don't think it matters what planet we're on. Polar, too high. Rohan, Amy, George, yes. What are these random units people are giving me? I'm ignoring you if you're giving me random units or no units. Hannah, yes. Brian, yes. Okay, don't put your answers in the Q&A, please. Just in the chat. Troy's moved on to question 3. No, far too low. Okay, a little bit of a spoiler. Lots of people getting the right answer now. Acorn, Ben, and Carol all got the right answer. So this is a conservation of energy. Obviously, we're not going to work out A. We don't know the height. We don't really care about the height, actually. So in the second scenario, you've got kinetic energy plus gravitational potential, and that's all being converted here. So I'm going to give you 1 minute to try and lock in a correct answer, and then I'm going to spoil this one and move on to question 3. So Eliza's got the right answer. Is it okay to use other approaches? Peter, if you can find another approach that works and it's valid, then yes. However, The point of this session is to try to find the most elegant, the easiest approach. Okay. Grace has asked for the link to be sent again to the question pack. So please post that in the chat if you can, Kat. Elliot, you have the right answer to question 3. Square root of 19. I've said no calculator. Miriam, that is correct. Square root of 7. No. I don't like square roots. That would be absurd. Give me a nice decimal answer. Justin, correct. Barati, correct. If you want to solve it with work done by gravity, well, that's just conservation of energy. Okay, so conservation of energy. Let's have a look at the scenario that we've got. We're ending up with kinetic, and that's all being transferred from the gravitational potential plus the initial kinetic. But we know that this gravitational potential, mgh, is just going to be equal to half mv squared. So now we have this scenario, which we can factorize and then cancel. So that gives us w squared must equal v squared plus u squared. And you will notice that I have given you very nice numbers because it's a lovely Pythagorean triple. So 5 meters per second. Okay, the most common wrong answer is 7 meters per second because you think these things you can just add linearly. A couple of people went for that, maybe more actually. But no, this is how we add energies. Okay, so Troy, I think I already told you, question 3, you have the right answer. Alice, you are too low. Harry, you are far too low. So Troy is blasting through, as is Peter. Oh, there's 2 Peters. Peter David, you are correct. Peter not David, you are too high. Arya, too high. Nihar, too low. Carol, yes. But there's always a question mark. Have some confidence. Matthew, I'm not sure you've understood the question. That's far too high. Debangshu, yes. Anima, yes. It's going very quickly. I'm just going to call out the right answers that I see. Ben and Jack and Miriam. Rohan. Lots of people coming in with 600. 600 is too high. $538 is too high. 356 is too low. Oh, Yitian, so close. Okay, Amy. Oh no, I thought you had it, but actually Harry's got it. Adam's too low. Amber's too high. Dennis has it. AW is too low. Okay. Oh, 522. That's an interesting number. No, it's not really, actually. Amy, yes. And James, yes. And Herb. We're getting probably about 1/3 of the people getting the right answer now. Those people who have got the right answer, which includes Teniola, are you doing it the long, tedious way, or are you being smart about it? Okay. If anyone thinks that they've spotted the trick to this one, you can just pop it quickly in the chat. Okay, Carol, I like it. Carol's done it the quick way. Charlie's has got the right answer. Lots of people doing double counting or triple counting for the corners. You don't need to worry about any of that. Anima, I think what you're saying is essentially correct. Okay, so Amy as well. I think you've pretty much put the nail on the head there. Ask the opposite question. if I were to ask you how many cubes are on the inside, all of a sudden, this becomes very straightforward. It's a bit like a probability of something happening question when you just ask the opposite. What's the probability of it not happening? And then I subtract 1 from that answer. So if we strip away the outside cube, so everything on the surface, you're just going to be left with an 8 by 8 by 8 cube, which of course has 512 cubes that are on the inside. So by a process of elimination, that means there must be 488 on the outside. Janina's asking, why is it not a 9 by 9 by 9? Because it's three-dimensional. The surface is a back and a front, a top and a bottom, a right and a left side. Okay, question 4. If you've posted any answers to that, I've ignored you up until this point, but feel free to start posting your answers to question 4. Okay, Troy, yes, I'm happy with that. James is asking, does it mean by concentration or by volume? I'm going to say volume. Okay, Elliot has the right answer. Hathaway has the right answer. Oh, some people are trying to put numbers on it and do the calculation. Anima, I think you've spotted the trick to this one, let's say. AW, yes. You can work out the numbers if you wanted to work out the numbers, but there's no need to. So how could we logically answer this without thinking about numbers and doing the calculation? Okay, I'm not telling people who've got it wrong because that kind of gives the game away a little bit, but my silence might also. Kitan, I am down with that answer. Okay, those who I've said have got it correct, which now includes Hina. If you want to send me your logical argument, we'll see if it matches. Amy, yes, I'm with you on that. Okay, Talia, there's a very simple explanation, which is much simpler than the direction you're heading in. I think I'm on the same page, but if I try to explain what you've just said, I think lots of people would be confused. Okay, so lots of people using the numbers to discover. What are we discovering? That it is actually the same. If you do the numbers properly, it's a trick question, but I'm not going to give you a 50-50 question, am I? That's ridiculous. But it is the same. So now we know that it's the same. Without doing any maths, can we come up with that logical argument? I've got they cancel each other out, but that's not really enough. Okay, Morgan, I'm kind of with you. I think you're explaining it right, just not as concisely as maybe it could be. Okay. Oh, Carol. I think that's pretty concise. Okay. So I'm going to tell you what Carol said. She says, what one gains loses in its own liquid, it gains in the other. So let's see what my explanation was for this. So I've said each glass starts and ends with the same total volume of liquid. So any gin that is missing from one glass and therefore in the other must have been replaced by tonic of the same volume that's come from the other, and vice versa. So they both start with the same volume and they end with the same volume. So some mixing has gone from one to the other. So if some tonic has gone from one glass into the gin glass, then that same amount of gin must have gone from that glass back into the tonic glass for them to have the same volume. That's essentially it. So no need to do any complicated maths. You can, of course, work it out, but that's not what I'm asking for at this point. So there's a nice kind of like logical way to think about it. Okay, a few people arguing with this. I'll let that stew for a little bit, and maybe if we've got time at the end, I might try to explain it again. But you know, I think if you think about it and you've got like different coloured marbles and you're pulling some marbles from one glass to another, it'll kind of make sense. Okay, let's move on to question 5. So we've got 2023. Oh, interesting number. So we've got that many participants running in a race, and they've all been labelled with a number completely at random, not based on ability at all. So what is the probability that the first 3 runners that cross the finish line do so in ascending order? So it could be like 8, 500, 752. That would count. Anything like that. Okay, Troy is already on to question 6. I must have missed your answer to question 5, Troy. Please pop it in again. But yes, for question 6. Okay, so Callum's got this. Azim has it. Paolo, it's less likely than that. Elliot, don't give me a question, give me an answer. Well, I don't want a calculation. Yeah, I'm not using a calculator. You're not using a calculator, but I want an answer somehow. Aria, question 6, no. Too low. Yes, Troy, I think I mentioned that's fine for question 5. Yitan, I feel like you're giving me a calculation. No, I just want an answer. Give it as a fraction. I'm happy with a fraction today. Normally I'm not, but probability, I like fractions. Hathaway, James, you're correct. Rohan, it is more likely than that. Janina, more likely. Peter, higher. Victoria, less likely. Elliot, how did you get that number without a calculator? Don't give me a calculation, Catherine. I'm not going to do it. I didn't get to sleep until 2:30 this morning. Well, I didn't get home until 2:30. It took me longer to get to sleep. I'm not in the mood to do crazy factorials. Yes, Morgan. Acorn, it is less likely. Hibber, give me a nice fraction, please. Nice fraction. Toby, you must have me on mute or something. Don't give me a calculation. If you're on question 6, you can leave this in surd form. I am expecting a surd for question 6. George, you are correct. Victoria, It is more likely Hina, correct. Okay, coming in quite quickly now. So I'm just looking for correct answers. Okay, but the correct answers are starting to dry up. So let's drop a little hint. Turns out I ask this question every year. Last year, there were only 2,022 runners. The year before, 2021. The answer doesn't change. It doesn't really depend on the number of runners. Okay, Alexander, question 6. That's too complex. No. Oh, a correct answer from Sai P. Lauren, no for question 6. Amy, yes to question 5. Ivor, no to question 6. I'll give you a clue, those people who are giving me crazy numbers. It's quite a nice fraction. Okay, Kitan, you've given me some working, but you've got the right answer, so I'll take it. Alice, yes. Sion, yes. Henry, yes. Okay, I've not seen correct answers to question 6 yet, other than that first one, I think, from Troy. Acorn, yes to question 5. Okay, let's drop another little hint. I mean, this is a massive spoiler. Yes, Justin. If I don't get another 100 right answers in the next 30 seconds, I don't know what we're doing. Yes, Polar. Okay, Carol, Catherine, Eliza, Amelia, sorry, Harry, yes. Anima, Mia, yes, okay. Massive spoiler, of course it was. So, there are only 6 possible ways that you could order the first 3 people in the race. So replace the numbers with letters if you want. And only one of those combinations, all of those are equally likely because they've been assigned randomly. So when you replace those letters by the numbers, only in one of those 6 cases is it going to be in ascending order or descending order. Most of the time it will be some kind of jumble. So it's a 1 in 6 chance. Okay. So lots of people going off on thinking they know too much maths and thinking that 2023 was important. But when we boil it down and think about it, just focusing on those 3 people, the first 3, you know, the remaining 2020, we don't care about. It's just those first 3 that we care about. Okay, answers coming in for question 6. So this is a little bit of geometry. Can we, Amy, yes, you can. Can we think about drawing a straight line in 3 dimensions? Herb has got it. There might have been some other people whilst I was talking about question 5. But if you've got more than one term, so if you're adding a couple of things, no, this is just going to be a single straight line. I want to know the length of this straight line. Verona, I think I'm going to accept that, although that is not how we write square roots. SQRT is the general abbreviation for square root. Aha, Troy has got stuck. No, Troy, that is not the right answer. And there I was, suspicious that you were just looking at the answers and spamming them in quickly. Harry, yes. Yitan, yes, I think that's right. Kitan, yes. Polar, you're close. Sivad, yes. Okay, let's have the first little spoiler, which I've kind of already mentioned, that you want a straight line. So you need to turn the cube into a 2-dimensional net, I believe is what they're called. So I think Harry's there, Teniola, Rohan, Isabella. Good to have you on board. Toby, yes. Okay, Kitan's asking how come it will travel a single line instead of across two faces? Well, if yes, Ben, and Peter David. So let's draw this diagram. When you draw the diagram, our net looks a little bit like this. So if we consider where opposite corners are when we fold this, Emily and Henry have got the right answer. Hathaway, yes. Pola, yes. Miriam, yes. And Barati, I think most of us are getting it now. There's still a few wrong answers coming in. Yes, Elliot. So if we identify that these points are opposites, a Badiola, yes. Then you just have to work out the length of that line. I'm expecting a flood, and I am getting a flood. Yes, Justin, Erin, Atava. Come on, Elizabeth, have another go. Aria, Carol. Sai, P, Sashin, yes, yeah, okay. We can do Pythagoras. Yeah, it's Pythagoras again. Lovely. So square root of 5 times the length of the sides. So if you fold this up again, you will find that that is where it needs to join, kind of halfway across the crease here. So it goes halfway and then it goes up, and then this is essentially a straight line, but in 3-dimensional space. Crazy. Okay, question 7. This is one of my favorite questions. There's a little backstory that goes with this. So if you'll indulge me, essentially, I had a big field and I wanted to mow it, but I didn't have a mower and I wasn't going to buy one because diesel prices were going through the roof. Actually, diesel's cheaper than unleaded at my local station, which is quite strange. But I thought, you know, fuel prices, they're generally only going in one direction. I don't want to invest in a mower. So turns out I've got a friend who's just starting out a uniform cow rental business. So I say, this sounds like the perfect pairing. Please, can I rent 6 of your uniform cows to graze my field? And they did it, eating away at all points, at all times, day and night. And after 4 days, my grass had got down to a level that I thought, this is acceptable. Let's have a big party. And I got the marquee in and we had a barbecue and I invited everybody that I knew. Lovely stuff. Next year, I'm in a similar situation. The grass has overgrown again. So I go to my mate and I say, oh, can I get some cows from you again? It's like, actually, you know, word of mouth after that party you had, epic, by the way. You know, the uniform cow rental business is starting to boom. You can only have 3 this year. I say, yeah, no, that's fine. Okay, get them in. They're doing the job. I'm a little bit confused because this time it takes 9 days, but the cows are completely uniform. Weird. Anyway, 9 days later, my grass is down. I get the marquee in again. We have another epic party. We spread the word about the uniform cow rental business. 3rd year comes along. Okay, this is becoming a tradition. People are expecting me to host this party. Grass is overgrown. I go to my mate. It's like, only because we go way back 2 years. I can give you 1 uniform cow, but there's a big waiting list. People are, you know, booking them left, right, and centre because diesel prices have skyrocketed. Anyway, so I think, oh no, what if everyone's having these like parties? I need to pre-book the marquee. So question is, how long is it going to take one cow to graze my field to get it down to the level that I'm going to have my party? So I can pre-book this marquee. So let's have a look at some of these answers. Amelia, too long. And what's this? Troy. Oh, second go is closer, but it's too high this time. Ben and Hathaway. I'd love to see your working. If you did it without a calculator, explain it to me, please. Oh yeah, too low. Peter D, too low. Physics in action, says Hina. Is that a comment on my story? Peter C, too low. Sire P, too low. It's not a fraction of a day, Yitian. It's a nice integer. Strangely, that's how it worked out. Henry, too low. Callum, too low. Hiba, too low. Matthew, double it and you're still too low. Okay, Hathaway, I'm liking this first chunk of explanation. So if you've not figured out why it is not linear, that's the first thing you need. You can't just be guessing numbers. Okay, Troy's figured it out now. Janina, too low. Teniola, this is never going to happen if it's going to be more than a year. It's definitely less than a year. Harry, too high. Shrinjoy, too low. Verona, too low. Don't give me fractional days. It's not a fraction. And you don't need to round it. Okay, let's start giving the hints. Why is it non-linear? It's not a geometric sequence. Think about the physics. It takes longer in the second year because the grass is growing. That's why I've got the problem. It's sunny, it's wet. It's a great British summer. The grass loves it, it grows, it keeps on growing, even as the cows are eating it. Catherine having a bit of a brain fart. Adam, too low. Oh, Hathaway, okay, you're giving me equations that may or may not work. They seem to work for you, so I'm assuming it's correct, but I don't know what X and Y are. Oh, maybe I do. Okay, Troy's getting ahead of himself and enjoying the drama. Okay, I'll give you a clue. It's more than 40 days. Most answers I'm getting are less than 40. Amelie, yes. But when you know it, you know it, you know? Yeah, it's one of those ones. When you've got the right answer, you know you've got the right answer. So the grass is growing. Next little hint. Think about what a cow day represents. So sometimes you might have heard the phrase of man hours, which is often used as a unit of work. Nowadays, you might want to be PC and call it person hours, but essentially it's the same idea. I was coming back from Belgium yesterday and somebody made us late through border control because they forgot their visa. And we were delayed by 2 hours, but there were 46 of us. So we lost 92 man hours because somebody couldn't bring their visa. Anyway, Priya, you have the right answer. Callum, did you not hear me when I said it's more than 40? Sashin, you were listening, but it's more than that as well. So a cow day is essentially a volume of grass. So what is a cow day per day? It's not the same as just a cow. You can't cancel out days like that. So think about the volume in each year. 24 cow days is consumed in the first year, but 27 cow days is consumed in the second year. From this, you could probably work out the growth rate of the grass. Yes, Troy, the piranhas will rise. Rohan, Saipi, you know. Move on. Some people forgetting that I did say it was more than 40. If you've got an answer that's less than 40, you don't need to enter it in the chat because it's not going to be right. And yes, it is possible to do this without a calculator. Possible, a little bit tedious. It's possible to do it in your head, but it's better to do it on paper. So, Janina, too high. Okay. Answers are slowing down, so I think more spoilers are needed. Okay, Kitan, it's higher than that. So, daily growth rate. The difference in the amount of volume that's been consumed is 3 cow days. So it's grown an extra 3 cow days worth of grass, but it did that in 5 days, the difference between 9 and 4 days, right? So that gives you a growth rate of 3/5 of a cow day per day. And you can't cancel out those days because they mean different things in this context. So can you work out how much volume of grass there was when I called the cows in the first place? That's probably the next step. I forget who it was, but somebody mentioned the kind of relative progress. So 1 cow, by definition, can eat 1 cow day's worth per day. But if the grass is growing at 3/5 of a cow day per day, well, it's going to make progress, but it's not going to be quick. Okay, Troy, thinking about question 8. Yes, that is how I'm essentially going to think about the analogy to this one. So you can relate it to that field. Different field to the cow field. Amy, come on, move on. Don't give me a question mark when you know. Hibber, no units. Lots of people with no units here, but also too high. Morgan, too low. Spoilers coming very soon. Yes, Henna. I think we've had less than 20 correct answers. That's what it feels like. I've not been keeping score. Matthew, too high. Janina, too low. Miriam, too high. So the progress. The net progress is going to be 2/5 of a cow day per day. So if I can work out what there is to start with, and every day I'm going to reduce that by 2/5 until I get down to 0, essentially. How many days will that take? Justin, that's too high. Okay, Troy, you have gone way off course. I don't know. You've taken some kind of diversion. Yes, Carol. But please include the unit. This is physics. It's not just maths for a bit of fun. This is meaning. This is real life. This is an epic party at stake. Thank you. Okay. Yes, Troy is seeing the error of his ways. We're all going to get there in a moment. So, turns out there was 21.6 cow days to start with. If we subtracted 4 days of growth from the first year or 9 days of growth from the second year, knowing that the growth rate, which we're going to assume is constant because everything here is uniform, if I've not made that clear enough. So therefore, it's going to take 54 days, chewing at a rate of 2/5 of a cow day per day, net. Yeah, so you're chewing at a rate of 1 cow day per day, but it's growing back at 3/5 of a cow day per day. So There we go. Let's have a look at Sarah Connor and Kyle Reese. Essentially, Kyle, is it Kyle who needs to go and take water to Sarah's house? Or maybe it's Sarah who's taking it to Kyle's house. I forget. Normally I do this with my gran because I'm trying to get myself into her will. And she lives out in the desert. She's off the grid and doesn't have access to utilities like running water. So therefore, every day I decide to be the charming grandchild that I am, and I will go down to the river and I will fill up a bucket of clean piranha infested water and deliver it to my gran. But I do not want to walk any further than absolutely necessary. So what is the minimum distance that I can go from my house, in this case Sarah's house, to Kyle's hideout via the river at some point? So I'm 3 kilometers away, or Sarah's 3 kilometers away from the river perpendicularly. 2 kilometers away is Kyle's hideout, and we are separated by a parallel distance of 12 kilometers. Okay, and again, no calculator is necessary, so that is maybe a big clue. Verona and Kitan have the right answer. Ben, you are giving me an approximate answer. I do not want an approximate answer. I want an exact answer, please. Okay, Troy has also figured it out. So just going over how I find out the initial volume of grass. So in year 1, I knew after 4 days, a total of 24 cow days worth of grass had been consumed. If I've worked out the growth rate by looking at the difference between the 2 years, and the growth rate is, what did we say it was, 3/5 of a cow day per day, well, I can just take off 3/5 4 times to work out how much there was at day 0. Okay, let's have a look. Ben, I mean, do you believe that's exact, or are you just going with it? Anima, yes. Harry, yes. Polar, yes. Matthew, yes. Niho, I'm not sure how you could possibly do it in 3 kilometers. That would get me to the river, but I'm nowhere near Kyle's hideout. Okay, I've seen a message directing me to Junari, but I can't see an answer on there. So if you had an answer and I've skipped it, please put it in again. 17 kilometers is what we're doing. We're going straight down, straight across, straight back up. That gives me 17. Well, if you look at this little red path, that's clearly going to be less than 17. That's got to be more efficient. Yeah, the hypotenuse of the triangle's shorter than the sum of its 2 sides, so 17 is too high. Peter, yes. Sai P, yes. Emily, we've done so well, and now you're giving me a nasty calculation. Stop it. Morgan, yes. Okay, so asking, explaining this question. So without the story, essentially, I want to go from Sarah's house to Kyle's house, and I want to go via the river, and I can go anywhere on this river. So I just need to pick a point. So maybe I could go straight down, and then I could go across here, and then my total distance would be 3 plus the square root of 12 squared plus 2 squared. But you kind of need a bit of a calculator to give me that. So that would be you know, that would be shorter than 17. Maybe I could go straight down and do 2 and then go across here, and maybe that would be shorter still. So that might be even better, but maybe there's somewhere along here that's actually the optimal place to go that will minimize the distance that I need to travel. Toby, that sounds like a calculation you're giving me. Emily, thank you. So let's start putting in the spoilers. There's kind of a big spoiler already with this diagram. So perhaps Yitan's suggesting the halfway point. So going for 6 kilometers in here, and then you could try it and see. You'd probably need a calculator, to be honest, if you're doing that. But yeah, that would be better than the last one I suggested, but would it be optimal? Does it work with values other than 2 and 3? To assume that they were congruent. Oh, posh word, mathsy word. Basically, I think you mean similar triangles. If you gave me a problem like this, no matter what the numbers are, I would apply the same method to answer it. If you gave me awkward numbers, I might need a calculator. Miriam, yes. Okay, I do not want square roots in this. So let's think about where you might be going wrong. So you might pick along here and make this a variable and call it x, and then this other side would be 12 minus x, and then you could, you know, set up your total distances in terms of x, and then maybe you could differentiate with respect to x to try to minimize it and find the second derivative if you wanted to prove it was a minimum. Fine, you could do that, but that is long and boring. Do not do it that way. I think Troy, when he was looking at this, he made the analogy with light. And imagine that instead of this being a river, it was a mirror. So if I were to shine a laser from this mirror to get to Kyle's hideout, it would only reach at one particular angle. So that tells you something about these angles. And light likes to travel in a straight line, and as we've already seen with the ant, a straight line is the shortest distance. But it's not a straight line because it bends. Or is it a straight line? I don't know. So triangles, congruent or similar, there's a 2 to 3 ratio. So we can use this 2 to 3 ratio to split this 12 into 5, and then you can put a number on this length if you wanted to. But that still gives you 2 nasty calculations, or maybe 1 nasty calculation. You could work out what this one is, and then you realize that this is just 1.5 times that because of the similar triangles. And yeah, but that's still quite nasty. Iara, Sion, you have the correct answers. Gravitational lensing. Are you talking about the same question, or have you gone off on too far ahead? Miriam, I don't know if we said you were correct, but you were. Alice is correct. So how can we turn this into a straight line? Well, if you know lenses, gravitational lenses, doesn't need to be gravitational. If you know normal lenses, then you can just extend the line and have your imaginary line going the other way once we've realized that the angles are the same. And extend this line. Is that going to happen on here? Oh, it is. So this distance is the same as this distance. I've just taken a mirror image, and now this is just a single straight line. It is the hypotenuse of a 3 plus 2, 5, 12, 13, Pythagorean triple. Pythagoras, he's there again, 3 times, boom. Okay, so 13 is a straight line distance, and therefore it is the minimum. You might see this kind of idea used in fiber optics. If you're looking at fiber optic cables and the path length traveled when it's kind of just below the critical angle, so you can compare the ray that goes straight through the fiber optic with the ray that is bouncing maximally along the fiber optic cable. Rather than do all of those bounces, just turn it into a straight line. Yeah, why not? Okay, so let's move on to question 9. We've got 23 minutes for 2 questions. This is the trickier of the 2 questions. Question 10 is pretty straightforward. This is a tricksy one. So we'll spend maybe 15 minutes or so on this. So we are traveling from Newcastle to Oxford, and we happen to be in a vehicle that has 3 settings, depending on whether you're traveling uphill, downhill, or on flat road. And if you're traveling uphill, you will travel at 56 miles per hour. On a flat road is 63, and downhill you will go at 72 miles per hour. So those numbers have been chosen very specifically to allow you to solve this question. That is something I would say. There's something special about these numbers. The last question, same technique, no matter what numbers you would give me. This question, look for something special in those numbers. That's a little hint. So going there, it takes 4 hours, but coming back, it takes 5 hours. How far is it between Newcastle and Oxford? Not necessarily what Google Maps would say, but in this fictitious scenario. So a few answers have come in. The most recent one, Anima, yes. Yeah, I mean, I'm sorry that it's in miles and not kilometers. Technically, we are a metric nation. We agreed that when we were given by Paris Greenwich Mean Time. We were allowed to be 0, have the prime meridian. Paris wanted it. Canada came along and said, well, how's about you have a compromise? You let London have prime meridian, and in return, they will switch from being imperial to metric. And we said yes, but we didn't say when we would. So technically we are metric, but still, how tall are you? 6 foot? How much do you weigh? 12 stone? 4 pounds? Yeah, we're metric. Matthew, close, but higher. Joe, halve it and you might be close. Shrinjoy, I feel your pain. These are tricky questions the first time you see something similar to it. When you start seeing these kind of questions over and over again, you will learn the tricks. So I have chosen these deliberately because there are lessons to be learned, different ways of thinking than what you've been taught in school, than what you're used to. Yeah, you should find these both uncomfortable and informative at how easy they can be. This is not easy, but it is solvable. Troy, don't give me a calculation. You can give me a decimal, but don't make me calculate it. Did you not hear me getting back from Belgium at 2:30 this morning? I've got to go to Reading tonight. I've got to get on a train and go and visit another school. It's crazy. Hathaway, yes. Matthew, yes. Okay, we seem to be forming a pact of people who have got nothing correct so far. But that's fine, because you're persevering and you're still here. You might get question 10 correct. Question 10's, I don't know why I put it last. Really, this should be the last question, or the cow question. These are the hard ones. Where are we? Matthew, you've got it right. Troy, yes, thank you. You've got it correct as well. Oh, Troy, if you didn't like the cow problem, you're not going to like the envelope problem. When am I going to talk about the envelope problem? Maybe in the next session. But then it'll haunt you. It haunted me for 10 years, that problem. George, you're close, but you're too high. Yes, Henry, lots of people getting there now. Okay, let's start dropping some hints for the rest of us. Actually, I don't need to make a video on the envelope problem. If you're subscribed to Up and Atom on YouTube, the lady there does a very nice job of actually explaining it, and she put me out of my misery because she gave me the answer, and yeah, now I never will because she spoiled it for me, but I do appreciate it. Okay, so let's label these distances: X, Y, and Z. Why not? A, B, C, doesn't really matter. But when we go in the opposite direction, Z becomes X, but Y stays the same. Y is the flat bit. If it was flat going there, it's flat on the way back. Okay, but if it was uphill going there, it's downhill on the way back. So now we just use some GCSE physics because we can work out time if we know speeds and distances. Well, we don't know the distances, but we've got, you know, some algebra for the distances. So let's set up some simultaneous equations. Amelie, I don't want a calculation, but I can tell you that if I were to do that, I would get the wrong answer. Shrinjoy, are you talking about the envelope problem? Do you know what it is? Double or quits? Yeah. Oh, it's nasty, but beautiful. Okay. So we've got a good 5 more minutes on this one. Now we can start doing the algebra. There's something you need to notice. Something you need to notice about those numbers. And maybe they're factors. Okay, just noticing in the Q&A, Ari's asked something about air resistance. I'm just spotting this about an hour later than you've posted it.
Oh, don't worry, Justin. I've been telling the kids that we can come back to all of these when we get to question 10. So we've got a nice sort of chunk of a few specific questions that should only take us a minute or two to race through.
Lovely. Yeah, I'm just wondering whether it was related to a particular question of mine or just a general question. Okay, Kitan is suggesting they're all divisible by 9. 56 divided by 9 doesn't work, but the others are. So yeah, the others are divisible by 9. That's useful. There's no shame in that. Kitan, you've moved us forward. 2 of them are divisible by 9. That's useful. Henry wants to know, is this question possible if the uphill and downhill velocity is not the same distance away from the flat velocity? I'm trying to understand that question, and I don't think it matters. Fathers realize they all have 2 factors from 7, 8, and 9. That is useful. Someone else has spotted that as well. Quite a few people now spotting that they share two factors. Okay, so hopefully we've made equations that look like this. This is just speed, distance, time for the total journey. So now, if we write them out as their factors, then we can kind of simplify. Harry's moved on to question 10. Yeah, you've got that correct. Harry, remind me, did you get this one correct? Troy is on to question 10. Sashin, it's a little bit higher. What do the simultaneous equations mean? Good point, because if you wrote this and I was your teacher, I would not be very happy, because you should write the equation first. So the 4 and the 5 here represent distance. No, they don't. They represent time. What am I talking about? So time is equal to distance divided by speed, x over 56. X miles of uphill plus y miles of flat plus z miles of downhill. That's what's going on there. Psi p, yes. Okay, so if you've spotted the trick about the factors and these numbers, what you need to do is multiply by 504. Why 504? Do it and see. What happens when you multiply by 504? Oh, Troy, you've moved on to question 11. Lovely. I'm not planning on doing that today. Let me just... Oh, that's on the next booklet. Troy, I don't have that booklet open. Can you briefly give me kind of like a 1 or 2 word clue as to what question 11 is about? Okay, Alice says you can only find X and Z. You don't need to find X and Z. Remember the ball falling down or rolling down the hill? We don't care about gravity. We don't care about height. I don't care about what X is and what Z is, or what Y is. What is it that I actually care about? What am I trying to find? What a relief. Is that the clue, Troy? It's still lost on me. Yeah. Maybe Troy's gone off into a parallel universe. There are more questions similar to this that you will have to work on, and then your mentors, if you're in the mentoring group, will go through the solutions with you. Okay, so multiplying by 504, 9x plus 8y plus 7z equals, however, 7x plus 8y plus 9z equals, but what if we added those two equations together? Okay, Eliza has the answer. Debangshu, you've got the answer. What I'm trying to find is just total distance, x plus y plus z. Yes, Anna. Units. Don't fight. No, don't give me an M. It's, yeah, thank you. I'm depressed as well that it's imperial, but it is what it is. At least we don't use Fahrenheit anymore. Okay, Isabella and Nihar and Yitan. I think we're all getting it now. Now it's just maths. If you add those together, you get 16 lots of x plus y plus z equals something very large. And then you can just find out what x plus y plus z is. So 283.5 miles. So less than 5 minutes to answer this next question. Final question for today. Epic battle between the ninja and the pirates. Ninja, very shifty. He's kind of like 2 steps forward, 1 step back, but on average, he's traveling at 4 meters per second. The pirate, he's got a peg leg, so he's kind of like hobbling, but determinedly so at 2 meters per second. But the pirate has a companion friend, his parrot, who is going to fly at a constant 8 meters per second, trying to look the ninja in his eyes if he can find any kind of chink in his armor, and he's going to bounce back elastically, coming back to the pirate, and he's just going to squawk this intel that he's found before he bounces off the pirate again, back and forth many times, gathering as much intel as he can to help his pirate master, until eventually he gets crushed between these 2 epic forces. And we might find out who wins. Who knows? But the question that I'm interested in is how far in total does the parrot fly on his valiant suicide mission? So, Anima, yes. Although there's a question mark. Why is there a question mark? Surely you're confident. Amelie doesn't have a question mark. They've got it. That's the confidence I like. Okay. Sion's asking about the dimensions of the parrot and its width. This isn't biology. This is physics. We're going to model the parrot as a point particle. I don't know what you're doing with the cows, but I was modeling the cows as a uniform cow density spread evenly over my field, chewing everywhere simultaneously at once. That's what we do in physics. I'm sure you must have heard the joke, supposedly, about the spherical chicken. Anyway, I had an answer come in that was 30 meters. That's far too low. 80 meters, also too low. More sensible than 30. Verona and Jitian and Toby, you have the correct answer. Let's start dropping a little bit of a hint about what not to do. You could work out the point of intersection, the first point of intersection. Yes, Eliza, Jinawi, George, Evie, and James, all correct. You could work out the first point of intersection. It's going to be somewhere roughly over here. And then you could put the positions of everyone at this new point, and then you could run it again, and you might come up with an iterative infinite sum. And if you know your arithmetic or geometric series, you could probably work it out. But I wouldn't do that, because I am not a mathematician. I'm a lazy physicist. Lazy, clever, yeah, same thing. Priya, yes. Ina, I agree with you entirely. What are your thoughts on particle physics? Sion, yes. Do not do the maths approach. is my take-home message. The PAT will be split into 2 sections. There will be a maths section. So if you love the maths and you want to, get it out your system, you can do that on the maths bit. The physics section, okay, they're not all going to be like questions like this. Well, hardly any of them will be questions like this, to be honest. But this is just about teaching you ways of analysis. Polar, higher. Enna, yes. Kitan, no. So, what was the physics that we were using in question 9? Maybe that could be useful here as well. Janina, too low. Herb, yes. Why the question mark? Alexander, yes. I mean, there's a danger if you give me an exclamation mark that I might think you're trying to factorial something. But if you're confident, you can give me an exclamation. I'm not going to misinterpret it as a factorial for the next 3 minutes. Matthew and Anna, yes. Barati, too high. Vanessa, yes. Nobody being uber confident yet. Nemeth, Henry, correct. Erin, that's correct. Is anybody going to be confident in their answer? Give me an exclamation mark if you're really sure you've got it right. Justin, Toby, and Alexander, you've not given me the answer there. Did you get it right before? And I said you did. You can't give me an exclamation mark after I've told you that it's right. Ben, if that's the first answer you've given, well done, you've been brave. You've put your reputation on the line, but it's right. Of course it is. You knew it was. Because I'm fairly sure you were using the physics and realizing that the parrot's speed is always constant. So if you want to work out its distance and you know its speed, all you need to do is work out how long it flies for. How long does this battle take before they collide? "15 seconds. Yes, Anima. Dominic, 15 seconds is all it takes, traveling at 8 meters per second for 15 seconds. Boom, must be 120 meters. Dead easy. There are variations on this that are normally like about trains and a bee buzzing between trains, but trains travel faster than bees, so those are ridiculous. Unlike this question, which is entirely factual. This is where I'm going to end. I think we're going to have a look at some of these Q&As, see if there's anything that we can immediately answer, and then I'm going to get on a train to Reading. Lovely. So I will stop the share, and you'll have more of these problems for next week. And then in the new term, we're going to talk about circular motion. That's the next time you'll see me again. But I'm going to throw in some other questions a bit like this just to warm you up and teach you a few lessons. Thank you.
All right, thank you so much, Justin. So I hope that what everyone took from that is that we've really built on some of our, I guess, more standard problem-solving strategies that Rachel introduced. And we've seen that from your questions, those strategies take us so far, but there are some problems that really benefit from a second look and not getting stuck straight in with the maths and just thinking about it differently. So that gives us a really nice different approach that we can build on as we come through. We do have a couple of remaining questions in the Q&A that we might be able to get to, because I think you've covered quite a few of those as we've gone through. So we can run over a minute or two late. Barati, who's asked a specific Q&A set question about the PAT, we'll come to those next week. I'll run a PAT Q&A session for you.
Yeah, I mean, in terms of difficulty, it's all quite subjective. If you're practiced on this way of thinking, I very rarely find these questions difficult because I've seen something similar somewhere and I've got these kind of techniques. So it's about practice, whether it's difficult or not. If I were to do a PAT question, like, or a PAT paper, I would probably struggle because it's been a long time since I've done the kind of maths, first year university maths and physics. But you've been practicing that at your A levels, so hopefully you'll find that a little bit easier. So the meaning of the terms friction, air resistance, terminal velocity, how they can be calculated. What does air resistance mean in this context? Aria, are you able, you can add in the chat, what do you mean by this context? Because it was an hour and a half ago that you, no, just half an hour ago that you were talking about it. Okay, Miriam, are you still unsure about the gin and tonic question? If you can confirm if you'd like me to try and explain it again. Okay, so let's imagine that we've got two glasses and in each glass we've got some marbles. So let's say I've got 100 red marbles and 100 blue marbles. And, you know, I put them on the scales and they weigh like 100 grams. So I'm measuring them. So I know that they've got the same number of marbles in. If I take a handful of marbles from the red and I stick them in the blue, I can mix them up and do whatever. And then I take a handful of this now mixture and I put it back in there. So obviously some of the red ones moved and then got mixed, but then ended up coming back. If I put them on the scales again, and I kind of like just move something between just to make sure that they're both 100. So now I know each one has 100 in it. Each one's got 100 marbles. I know in total there's 100 blue marbles and 100 red marbles. So if this one has 80 red marbles, it must have 20 blue. What must be in the other one? It's got to be the opposite. It's going to be 20 and 80, but the opposite colors. So that's, yeah, the fact that we go now to liquids and the liquids can mix and it's very hard to tell them apart doesn't change the fact that whatever's gone from one is in the other must have gone vice versa. So there we go. Okay, goodbye if you have to leave. Yeah. Yeah, so thinking about marbles, it's just another analogy, a way to visualize these things that can be helpful. And a lot of physics, most of physics, let's face it, is about making models into something that is simpler, that we can understand and we can get our head around or have some kind of common sense approach to, which is why things like special relativity and quantum mechanics are so counterintuitive. Okay, I'm not sure if Aria came back with a response or if Aria is still here.
I didn't see a response come through to that one. I've been trying to clear some of the general Q&A ones while you've been doing the specific ones.
Okay, I'm going to ignore you, Aria, for now because I don't fully understand what the question is about, whether it's a general question or for anything specific we've gone through today. So Janina's asking about gin and tonic. Hopefully the marbles has answered that as well. How did I calculate the volume for question 7? It was about the unit of cow day. So it's how much grass one cow can consume in one day. So I had 6 cows eating away for 4 days. How much grass could they consume? 24 cow days. I just multiplied them together. So by definition, one cow can consume 1 cow day's worth per day. Somebody didn't get the calculation in question 2, which was 5 meters per second. I think I'll just very quickly reshare my screen. We go back to question 2, just to show that calculation. And maybe you can screenshot it if you want to study it very quickly. Okay. Ooh. Actually, I want to go back on here. Let's do it this way. Back. Can we see me frantically going backwards through the PowerPoint?
We can indeed. You're all good.
Okay, lovely. So this is where we're at. Just applying conservation of energy. So in the second scenario, half m omega squared is equal to mgh plus half m u squared. So that's just from this second scenario. But from the first scenario, I can substitute for mgh because that's just equal to half mv squared. So I've done that substitution and I've factorized. I've done 2 steps in one go. And then you cancel out and that just becomes w squared is equal to v squared plus u squared. Is there a physics course book, A-levels, you recommend for students not living in the UK? Get on to Isaac Physics. It's not really a course book, but it is about practicing lots and lots of high-level questions. And 40% of a general physics exam will be based on math skills that Isaac Physics will help you with. Generally, I quite like the CGP AQA guides or textbooks as well. That's my preference. Maybe I just like that exam board. So where would you find similar questions like these other than PAT papers? Generally Saturday about 9 p.m. ITV, 1% Club is kind of cool, kind of gets your brain in gear for those kind of things.
Just going to jump in there to save you a little bit, Justin. So an email comes out every Wednesday following these webinars that has plenty of links and answers a lot of these general PAT questions. So you can just focus on any specifically regarding your questions. You don't need to worry about those ones. But obviously, thank you for your input, but it makes it a more manageable load for you.
Thank you. Aria has reappeared. Apparently, we're looking at an extract from the PAT syllabus. So wanting to know how deep we need to go in terms of air resistance, because it's not taught in some A levels. Terminal velocity, knowing that it's proportional to your velocity squared is very useful. You probably don't need to go down into kind of like Stokes' laws for doing oil drop experiments, where strangely drag coefficients and things not proportional to velocity squared. But normally we'd just assume that air resistance is proportional to velocity squared, and of course surface area. And that's probably all you need to know. Kitan's asking about lacks of mark schemes.
Yep, so again, all of these, I'm sort of dealing with all of these ones, so you can happily stick to just any specific ones, Justin. You're all good. Okay. I've just emailed that one.
Lovely. So Amy thinks that for the cow question, it makes more sense to assume the cows need to sleep and the grass is growing at a non-negligible rate. Oh, Amy, don't hate me for the cows. They're uniform cows. No, they're eating all the time. All the time. Or if you want to include sleep in there, then assume that they're eating at an average rate and they take shifts to sleep. Something like that if you want. Okay, let's not get into the biology of it, please. Last step of question 7. Let's find question 7 again very quickly. Was this the cows? Yes. Okay. So, for Martha, hopefully this answers your question. And if we were able to get to 21.6 cow days being the initial volume of grass, assuming that we've got to that stage and realizing that the grass is growing at 3/5 of a cow day per day, and the single cow is making net progress of 2/5 of a cow day per day, then we can essentially divide this by 2/5 or 0.4 to work out how many days it will take. So you're doing 21.6 cow days divided by 2/5 of the cow day per day. The cow days cancel out and you're left with dividing by a day, which gives you days. Well, you're dividing by per day, so that gives you days, and it's 54 days. Sometimes the units will help you, even if they're ridiculous. Okay, that's the cows. It's a good job I'm not talking about the envelope question. If you really want the envelope question in 3 months' time, let me know, and I might finish with that.
Justin and the people who are left, I'm going to give you 2 more minutes, and then I'm afraid we are going to have to stop for today. So, Justin, speed answers.
Speed answers.
Yeah.
So somebody wants to know how I got rid of G. Are you talking about gravity? It just cancels out. It doesn't matter. It can be on any planet. It's MGH is just converted into kinetic energy, and I knew the kinetic energy. I don't know what G is. I don't know what H is. How do I get 21.6? So year 1, 24. Are we happy with 24? 6 times 4 is 24. Year 2, 27. 3 times 9 gives me the 27. I can use either of those, and I can work backwards. Let's work backwards from the first one. 24 days minus 4 days of growth. Each day of growth is 3/5 of a cow day. So 3/5 times 4, 12/5. 24 minus 12/5 is 21.6. Okay. I have a train to catch, and I've just realised I've not even had dinner. So I'm out.
Absolutely. Thank you so much, Justin. Everyone who is still here with us, I'm sorry we haven't quite got through all of those sessions, but remember, this session is being live streamed and recorded, and I will make the recording available to you tomorrow, so you can go through this in your own time and hopefully sort out those solutions. Thank you all so much for coming. Look out in your inbox first thing tomorrow morning for those emails from us. Have a lovely day and a lovely week until next week. Thank you very much, everyone.
Goodbye.